Hello everyone, so welcome back to this video. So in this video we will see how to use IDEA symmetric key cryptographic algorithm. IDEA or International Data Encryption Algorithm is a symmetric encryption algorithm which is known for its simplicity and its effectiveness. So it operates basically on a 64-bit blocks and use 120-bit key for encryption. So this algorithm has been widely used for secure data transmission and storage. So its strength lies in its ability to provide strong encryption while remaining computationally efficient. When implementing the encryption in your application, IDEA can be a valuable choice for ensuring data confidentiality and integrity. So without too much delay, let us implement this in our code in Java. So I have created a IDEA.java class. So under the symmetric cryptographic package. So we will follow this step to implement and use IDEA in our Java applications. So in step 1 we will add a Bouncy Castle provider, which can be done by using a security.addProvider method. Security.addProvider, and we will pass a Bouncy Castle object. So now we have completed step 1. So in step 2 we will use key generator class to generate a key for IDEA. So that can be done by key generator class. And the algorithm that we are using is IDEA with provider BC. The key size will be 120-bit key size. Key generator dot initialize by passing 128-bit 128. And now let us generate a secret key. Secret key is equal to key generator dot generate key. So now we have completed our step 2. So in step 3 we will create an instance of a cipher by using a cipher. Cipher is equal to cipher dot get instance. So our algorithm is IDEA in ECB mode with PKCS5 padding, and the provider is BC. Okay, so now let us initialize our cipher in encryption mode. Cipher dot init, and then we will pass cipher dot encrypt mode, and we will pass our secret key. So now let us take some input using scanner class. Scanner sc is equal to new scanner. Enter a message to encrypt using IDEA. String user message is equal to sc.next line. So this will take a user input from a keyboard. So in step 4 we will encrypt the user message. So let us pass our user message to our cipher, that is this cipher. So the cipher will transform these plain text into a byte array of encrypted data, which can be stored in encrypted data, and we can call cipher.doFinal method to encrypt our data. Do final user message.get bytes. So now let us convert our encrypted byte array into a base 64 format for better readability, which can be done by string cipher text base 64 is equal to base 64 dot get encoder dot encode to string and pass our encrypted data. So we will pass this in encrypted data, and now we can print our cipher text. S out encrypted message is plus ciphertext base 64. So now let us run our code and see what happens. Hello, please encrypt this message. As you can see, the encrypted message is here. So now let us decode this data. To decode this, we will again initialize our cipher in decryption mode, which can be done by cipher.init cipher.decrypt mode, and we need to pass our secret key. And after that, let us create a variable to store our decoded data. Decoded original data is equal to cipher.doFinal. We need to pass our ciphertext, that is encrypted data, which is in the form of byte array. So the return type is byte array. So let us convert this in byte array. So now let us print our data here. Test out the original message is plus our decoded original data. So we need to convert this into a string by passing it into a string constructor. So now let us run this code. Click here, click here. Hello, please encrypt this message. As you can see, this is our ciphertext and this is our decoded original index. So thank you for watching this video. Thank you. If you like this video, please do subscribe, share. Thank you.